All right, so this is a continuation of deriving the distance formula. So we're going to finish this video. So if you look at page 53 on the top right, it gives you a right triangle on the x and y plane, and it has this coordinate, which is x2, y2, and it gives you this coordinate, x1, y1. All right, so if you look at this point we called R in our example before. This was our Q and this was our P. So if you look at R had a coordinate in common with Q, and it was the x value, right? So we could say R is x2, and we could say that R is x2, y1, because it had the same y value as P. So the same y value goes for R right here. The same x value for Q goes here. Now, you don't have to memorize all this, okay? I just want you guys to appreciate how we got the distance formula in math. And you actually should know how to derive the distance formula from the Pythagorean theorem. Can you guys as a class tell me what the Pythagorean theorem is? Go. Equals c squared. Okay, cool. So A and B represent the legs of the right triangle. C represents the hypotenuse, right? So in order to find the x value, or the change in x's, we technically did x2 minus x1, right? We got that number, and that number we subtracted them from each other, and that's how we found the distance, right? That was our A value. And then our B value, this distance, the vertical distance, was y2 minus y1, right? So then we got that number, and we plugged it in into the Pythagorean theorem, right? So let's plug it in. Let's plug that in for A, and let's plug this in for B, right here. So A is x2 minus x1 squared plus y2 minus y1 squared equals c squared. But instead of doing c squared, what were we trying to find here? What was the thing we were trying to find? The hypotenuse, but what were we trying to find? The distance. What's a better letter to use for distance? D. So instead of putting c squared, can I put d squared here? Yeah, I can. I can put any letter I want. So I'm going to choose to put d for distance. Okay, how do I get d by itself? If I want to get d completely by itself, what's the inverse operation of squaring? Square rooting. So let's square root. What you do on one side, you do to the other. Now d is left by itself, and we're left with the square root of the change in the x values squared plus the change in the vertical values squared all over the square root will get us the distance. Ms. Panameño, this is ugly. No, it's not. Let me show you how powerful it is. So in our first example, we found that the distance was 13, right? You were given 2 points. We can use the distance formula now. So let's use the distance formula. This is going to be x1. Oh, that's so bad. I shouldn't use my fingers. We're going to say that this is x1, y1, x sub 2, and y sub 2. Now let's plug it in. Put the square root symbol. X sub 2 is 13. 13 minus 1 squared plus 9. Oh, it's supposed to be minus. 9 minus 4 squared equals the distance. What's 13 minus 1? 12. What's 9 minus 4? What's 12 squared? 144. What's 5 squared? What's 144 plus 25? 169. What's the square root of 169? 13. Do you see how what we did in like 15 steps? We just did it in 1, 2, 3 steps. We got the distance. It's pretty cool, huh? So, sure, you're supposed to act excited at least. So go ahead and write this distance formula down and appreciate it because we derived that from the Pythagorean theorem and a picture.